In this video, we will learn about lower bound and the upper bound. First quantity, it is the length. The length is given 127.3 centimeters correct to 1 decimal place. You are asked to find the lower bound and the upper bounds of this measurement. And you can see they have said that the lower bound is 127.25 centimeters and the upper bound is 127.35 centimeters, which the actual measurement is only 127.3 centimeters. Now let's see how to find the lower bound and the upper bound of a given actual measurement. Look at this example. The weight of a bag of potatoes is 25 kilograms correct to nearest kilogram. Write down the smallest possible weight of the bag of potatoes. So when they say the smallest possible weight, that means they ask you to find the lower bound of 25 kilograms, which is correct to the nearest 1 kilogram. Since it's 1 kilogram, you take 1 divided by 2 and you take the value as 0.5. I repeat, in the question it says 25 kilograms correct to nearest kilogram. So when they say nearest kilogram, what I do, I take the value 1, I divide it by 2, so my answer is 0.5. Thereafter, from this 25, I subtract 0.5. So the lower bound of 25 kilograms correct to nearest kilogram is 24.5 kilograms. Write down the largest possible weight of bag of potatoes. When it's the largest possible weight, they refer to the upper bound. So how do you find the upper bound? Similarly, you take 1, you divided it by 2, then value is 0.5. We are going to add this 0.5 to 25 kilograms. So, by subtracting 0.5 kilograms from 25 kilograms, we got the lower bound 24.5 kilograms. Whereas, by adding 0.5 to 25 kilograms, we got the upper bound 25.5 kilograms. Let's look another example. The length of a line is 63 centimeters. Correct to nearest centimeter. Write down the least possible length of the line. In this case, again, least possible length is the lower bound. So since they have mentioned here nearest centimeter, you just take 1 and divide it by 2. Nearest centimeter, just take 1, divide by 2. Then your answer is 0.5. Now as we did before, from 63, when you subtract 0.5, you will get the lower bound as 62.5 centimeters. Write down the greatest possible length of the line. Again, when it's the greatest possible length, they refer to the upper bound. How we find the upper bound? We add 0.5 to 63 centimeters. So 63 plus 0.5, upper bound is 63.5 centimeters, where actual length of the line is 63 centimeters, while the lower bound is 62.5, which you subtract 0.5 from 63. Upper bound is 63.5 centimeters, which you add 0.5 to 63. A field is in the shape of a rectangle. The length of the field is 340 meters to the nearest meter. The width of the field is 117 meters to the nearest meter. Calculate the upper bound for the perimeter of the field. So before we find the upper bound for the perimeter of the field, let's find the upper bound of the length of the field. Such, the length of the field is 340 meters. It has corrected to the nearest meter. So what we do, we take 1 and divide it by 2, which is 0.5. When you add it to 340 meters, the upper bound is 340.5 meters. Thereafter, we have to find the upper bound of the width. The width is 117 meters. It has corrected to the nearest meter. So we take 1 and divide it by 2. Then the answer is 0.5. Now we add 0.5 to 117, which is 117.5 meters. Thereafter, we are going to find the perimeter of the field. How we find the perimeter of a rectangle? We add the two lengths and we have to add the two width. But in this case, we add the two upper bounds of the lengths, which is 340.5 plus 340.5, and we add the two upper bounds of the width, which is 117.5 plus 117.5. Such, the perimeter of the rectangle is then, by adding all these values, it is 917 meters. This is the upper bound of the perimeter of the rectangle. The length of a rectangle is 30 centimeters. Correct to two significant figures. The width of a rectangle is 18 centimeters. Correct to two significant figures. Write down the upper bound for the width. So how are we going to find the upper bound for the width? We take 1, as we did all this time. We just take 1 divided by 2. Then we have 0.5. You add it to the given width. Then it becomes 18.5 centimeters. Thereafter, they ask you to find the upper bound for the area of the rectangle. How do we find the area of a rectangle? We multiply the length by its width. But you have to find the upper bound of the area. Such, firstly, we are finding the upper bound of the length. So the given length is 30 centimeters. As we did all this time, we take 1, divide by 2, then it's 0.5. You add it to the given length, then it becomes 30.5. Nextly, you find the upper bound of the width, which we already found. Now we know the upper bound of the length and the upper bound of the width. Knowing the upper bound of the length and the width, we find the area. We find the upper bound of the area, which is 30.5 multiplied by 18.5, that is equal to 564.25 square centimeters. A field is in the shape of a rectangle. The width of the field is 28 meters measured to nearest meter. Work out the upper bound of the width of the field. So, the width of the field is 28 meters. It is given. How do we find the upper bound? We take 1, we divide it by 2, then it becomes 0.5. You add it to 28, you can clearly see that upper bound of the width is 28.5. You can see the question asks the width of the field is 28 meters measured to nearest meter. Measured to nearest meter. That means it refers to 1 meter. But they say that the length of the field is 145 meters measured to nearest 5 meters. In this case, they have mentioned you that they have measured the length nearest to its 5 meters. When it's nearest to 5 meters, how do you find the upper bound and the lower bound? We take 5 and we divide that by 2. So for so long, when they said nearest meter, you took 1 and you divided by 2. Now they say that it's for the nearest 5 meter. When it's for the nearest 5 meter, we take 5 and divide it by 2, which leads to 2.5 meters. Now you add this to the given length, which is 145 meters. When you add 145 meters to 2.5 meters, your upper bound is 147.5 meters. The upper bound of the length is 147.5 meters. So what is the upper bound of the perimeter of this rectangle? How do you find the perimeter of a rectangle? You add the two lengths and add the two widths. Such in this case, they are asking from you to find the upper bound for the perimeter. So you are going to add the two upper bounds of the length as well as you add the two upper bounds of the width, which is 352 meters. The next question is, Steve measured the length and the width of a rectangle. He measured the length to be 645 millimeters, correct to nearest 5 millimeters. Now, we did in the previous question also, when something is corrected to nearest 5 millimeters, you take 5 and you divide by 2 for you to find the upper bound and the lower bound. So, when 5 is divided by 2, you get 2.5. You can add this to the given length, then it becomes the upper bound. When you subtract this from the given length, then it becomes the lower bound. So when we are doing this question, calculate the lower bound for the area of this rectangle. Give your answer correct to three significant figures. The lower bound of the length of this rectangle is 645 is the given length. You subtract 2.5. Why do you subtract 2.5? I said you specifically in this question, when it's to the nearest 5 millimeters, you take 5 and divide by 2, not 1. If they have said nearest millimeter, then you take 1. Now you have to take 5 and divide by 2. When you take 5 and divide by 2, it's 2.5. And when you subtract it from the given value 645, your answer is 642.5 millimeters, which is the lower bound of the area. Which is the lower bound of the length. Similarly, you have to find the lower bound of the width. Given width is 400 millimeters. You subtract 2.5, then you have 397.5 millimeters. Now when we are finding the lower bound of the area of the rectangle is length multiplied by the breadth, which is the lower bound is 642.5 and the breadth or the width is 397.5. When you multiply it together, you will get the lower bound of the area of this rectangle. And at the bottom, I have corrected it to three significant figures and have written the answer. The next question. A train travels along a track in 110 minutes, correct to nearest 5 minutes. So as we did and as I said, when they say correct to nearest 5 minutes, you have to take 5 and divide by 2 to get the lower and the upper bound. Jake finds out that the track is 270 kilometers long. He assumes that the track has been measured correct to the nearest 10 kilometers. Now you can see in this case, the length of the track is corrected to the nearest 10 kilometers. Could the average speed of the train have been greater than 160 kilometers per hour? So you can clearly see again the time is corrected to nearest 5 minutes. So you will take 5 and divide by 2, which is 2.5, for you to correct it to the upper bound and to the lower bound. And the distance is measured to the nearest 10 kilometers. So you have to take 10 and divide by 2 for you to find the upper bound and the lower bound of the distance. We know that the upper bound of the speed should be equal to the upper bound of the distance but the lower bound of the time. Speed is equal to the distance divided by time. So they want you to find the upper bound of the speed. When we are finding the upper bound of the speed, we have to find the upper bound of the distance divided by the lower bound of the time. So I have worked it in a small table over here. I have showed you the upper bound and the lower bound both in distance, which is 270 kilometers given. Upper bound means you add 5 kilometers, that is 275 kilometers. Lower bound of the distance, you subtract 5 kilometers from 270 kilometers. So that is 265 kilometers. Such I have written the distance corrected to the nearest 10 kilometers, the upper bound and the lower bound. Time I have written here. It is given in minutes. Actually, the time is given in minutes here. So I have first found the lower bound of the time, which is 107.5 minutes. How did I do? Find this 107.5. From this 110, I subtracted 2.5. And then how did I find the upper bound of the time? That is, for this 110, I added 2.5. So now I have the lower bound of the time and the upper bound of the time, but in minutes. So the question wants you to write the answer in kilometers per hour. So 107.5 minutes divided by 60, I can change it to hours. 112.5 divided by 60, I can change it to hours. So that the speed is equal to the given distance, that is the upper bound of the distance. We have to take the upper bound of the distance, which is 275 kilometers, and the lower bound of the time, which is 107.5 divided by 60 hours. The final answer is given in kilometers per hour. In this slide, I have shown you how to work out few lower bounds and upper bounds in case where the decimals are there. You can see that 15.2 centimeters. You want to find the upper bound and the lower bound. Then since there is one decimal place here, I will take 0.1 and divide it by 2. So then the value is 0.05. When I subtract it from given value, I get the lower bound as 15.15 centimeters and I get the upper bound when I add it as 15.35 centimeters. In the second case, you have 45.26 meters. So 0.26 meters, you can see here clearly there are two decimal places. What I did, I took 0.01. Why? Because there are two decimal places here. I took 0.01, I divided it by 2 and I subtracted from the given value to get the lower bound and I added to the given value to get the upper bound. Nextly, again I can see that 143.05 kilometers. Here you can see there are two decimal places. When you have two decimal places, that is, you have to take 0.01 and divide it by 2. When you have two decimal places, you take 0.01 and divide it by 2. Your answer is 0.005. You subtract it to get the lower bound. You add it to get the upper bound. Again, you can see there's only one decimal place. 100.1 milliliters, there's only one decimal place. When there is one decimal place, you take 0.1 divided by 2, which is 0.05. When you subtract it from the given value, you get the lower bound. You add it to the given value, which is 100.1, you will get the upper bound. And the last example, 12,500.3 kilometers. Again, you see there is only one decimal place. Guys, if there's only one decimal place, you divide it by 2 and you get 0.05. You subtract it to get the lower bound. You add it to get the upper bound. So, I hope now it's clear how to find the lower bound and the upper bound of a given value.